Hey again. Thanks for joining us for the next session of our Python and AI series, Vision Models. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel within 24 hours. With that, I'd love to turn it over to our presenter for today. Pamela, thanks so much for joining us.
Hello, everyone. Super excited to be here, as always, for our Python AI series. And we are about halfway through this series. For those of you who are new to the series, we've been talking all about Python with generative AI. And we've already talked about LLMs, vector embeddings, and RAG. So if you missed those sessions, you can catch up with the recordings and the slides. They're all available and linked, and we'll put the link in the chat. Today, we're talking about vision models, and then we've got 2 more streams coming up in the next week. So do register if you haven't registered yet for the series, because then you'll get all those links sent to you as well. So today we're talking about vision models. My name is Pamela Fox. I'm a Python cloud advocate. So that means my job is to help Python developers be successful with Microsoft technologies. And these days, that means lots and lots of AI. And it's been really cool to get to learn about all these new technologies and try to dive deep in them and see how to use them with Python. So today we're going to be talking about multimodal LLMs, and we're really going to be focusing on using them for vision, so using them with images. We're not going to be looking at audio today. So we'll look at popular use cases for them, how to build apps like user-facing apps on top of them. We'll also look at multimodal embedding models, once again, using those with images instead of text. And then finally, talk a bit about RAG with vision models. Now, if you want to follow along and actually run the same code that I'm running, then you can do that using this GitHub repository. That's what we're using for the first half of today. And we'll put this link in the chat as well. And what we can do is go to that link. So I've got it open over here in the browser. And then I click on code, this big green code button. And I see this code spaces tab. And I click create code space on main. So what this does is it opens up a GitHub code space in the browser. And a GitHub code space is actually, it looks like VS Code, Visual Studio Code, but it's running this particular project. So it's actually going to have the dependencies set up so that we can just use it. And the cool thing is that inside GitHub code spaces, it's really easy to use GitHub models, and we'll be using GitHub models today. And GitHub models are free for a certain amount every day. So for these demos, we can totally use the GitHub models, and we won't have to pay any money. So there we go. So now it's all loaded up. So now I'll be able to use it for the examples. It can take a couple of minutes to start up, which is why I like to do it before we go into the examples. All right, so now let's start talking about multimodal LLMs. What is a multimodal LLM? So multimodal generally refers to multiple modalities. These days, when people say multimodal LLM, they're often talking about images. Some of them do accept audio and video. I think most of them, like they all accept images, right? If you hear multimodal LLM, you can assume it accepts images. Some of those also accept video because they know how to chop the video into images. So a video is just like a bunch of images, right? A bunch of frames. And then a few of them might accept audio, but we're not going to be talking about video or audio today. We just don't have time, and there's not as many of the LLMs that support those. So a multimodal LLM can take both text and image, and it can reason about both of them together. It can generate a response based on both the text and the image, right? So what it does is that with the text, it turns those into tokens that it understands that it's been trained on. And we talked about that in our first session on LLMs. It takes the image And oftentimes what it does is it turns it into tokens as well in the same token space. This is one technique. There's actually multiple techniques that the multimodal LLMs use. So if you really want to dive deep into the machine learning of it, there's this amazing article by Sebastian Roschka, who's also written an entire book about LLMs with Python. If you want to go like really, really deep and actually build LLMs from scratch, that's the name of the book. So definitely check out this article if you want to see all the different ways that people are building their LLMs. But one way is that basically they both get turned into tokens in the same space. And a lot of times images do get split up into patches, right? So each patch would have a set of tokens, and those patches would get processed along with the text tokens. So they both get turned into something the LLM understand and has been trained on. That's the important thing, right? It's been trained on being able to understand text and images and being able to understand both of them together. And so those go into the model, and we get out possible next tokens, and then we turn that into text, right? And we say, okay, here's our answer according to the model. All right. So how can we actually use these multimodal LLMs? How can we get started with them? There's actually a number of multimodal LLMs now, right? So if you're going through openai.com, you can use GPT-4o and GPT-4o mini. Those are both multimodal. And we can use that via Azure OpenAI or via GitHub models for free. And so that's what we'll do today is we'll use GitHub models. We'll put a link to this GitHub models in the chat. So that you can check out all the models you can play with there. We also have Microsoft Research has the Phi family of models, and some of the recent versions of Phi do have multimodal support, and we can also use them in GitHub models. So let me go ahead and open up GitHub models so I can show you a few options here, right? So we go here and we say view all models. And category multimodal. Okay. So if you look here, we can see the OpenAI GPT-4o and 4o mini. We can see Phi 3 Vision Instruct. There's actually a new Phi 4 multimodal that's not showing up here. I told the GitHub models team to fix it so it shows up, but they haven't been able to deploy that change yet. So there is actually 2 Phi multimodals. And then you can see we've got 2 Llama ones. So these are from Meta Research, right? And these both have the ability to understand images. So these all pretty much only process text and image. And I saw, there's a question about video and audio. I actually don't see any of these as understand video. I did read through the Llama 3.2 research paper, and they talked about video and audio in that, but I think they didn't actually release it in the model itself. So you could read about how they were going about the video, but I don't think they actually put it in the ultimate released model. All right, so we can try out all of these models from GitHub models, and you can kind of compare and contrast and see what different responses you get, because they've all taken a different approach to being able to understand both text and images together. So let's see how we can actually send images to these LLMs. We're going to be using the OpenAI SDK in Python in order to do that. So I'll go back to this code space. And in this code space, what you'll find is a notebooks folder. And I'm going to open chat_vision.ipynb. That means it's a Jupyter notebook. And this notebook starts off with 2 different options for how to set up the OpenAI. One, actually, no, it just starts up with this, and it can either use GitHub or Azure or even Ollama. If you're using Ollama, there's some models with Ollama that support it. But we're going to be using GitHub. Let me change this. Let me run this here. Okay. All right, it's just installing everything that it needs here. Okay, and now it's connecting and running. All right, and let's see. Let me change this to default to GitHub. I thought I made this change. Okay, I'll check this out. But what we want to do is use the GitHub host. So we wanted to execute this code here. All right, let me go and take this. Let me make a .env. I thought I had changed this all, but okay. All right, I'm going to copy this .env and set the host to GitHub. And then we just need this GitHub models endpoint. Okay. All right, so then I'm going to restart this kernel to make sure it can reread that .env file correctly. And here we go. Okay. All right, so if you have any issues, you should make a .env just by copying the sample and then changing the host to GitHub. And that way we can try these all out for free. All right, so now we're connected to GitHub. So the first thing I'm going to do is send both text and an image to the LLM. And for this example, I'm sending the image using a URL. And this is a public URL that anyone can read, right? So, you could look at it, I could look at it. It's just public on the web and not protected by anything, right? And it's this picture here from Wikipedia. So I'm sending it with this absolute URL that's publicly available on the web. And so now it's looking at both the text, is this a unicorn? And it's reading in that image there and says, oh, no, it's not a unicorn. Possibly it's an oryx, which is correct. And it answers that correctly. Okay. So now it's great if you like all of your images happen to be public images, but most of the time you're going to be dealing with private images, right? You don't want to just have to put all your images available on a public URL just to be able to send them to an LLM. So what you can do in that case is turn them into what's called a data URI. And it looks like this: data::image/ping, if it's a ping, then base64, and then it's the base64 encoding of the file data. So that's a data URI. So what we're going to do is open the image. We've got this image locally in a file. We're going to open that image and we're going to turn that into a data URI. And you can do the same thing with images stored in, blob storage, S3, wherever, right? You just need to be able to get that image data and turn it into the base64 UI. So that's that function here. And it says, how could I make this into a unicorn? And it's going to open that local file, right? And turn it into a base64. So the API call looks the same. The only difference is that this time we're sending in a data URI instead of a URI that starts with HBS. All right, so I've asked it, how could I make this into a unicorn? It's going to think really hard. One thing that was funny, I tried this question with an early Phi multimodal, and it said, I can't turn this into a unicorn because unicorns don't exist. And I was like, well, that's fair. That's fair. Unicorns don't exist, but you could be a little more creative. So it's really interesting when you try things across different models, because some models will overthink it, or will not be so inclined toward creativity. Other models really like being creative. This is taking too long. I'm gonna just try running it again. Like sometimes, here we're using GitHub models. So if all of us, using it at the same time, maybe we're, causing it to be a bit slower. I can also switch. I've got the same code running locally. Let's see, not this one, this one. Okay. Let me run this and then run this. And this one is running with Azure OpenAI. So this is, that one was faster since it's dedicated, for me. It's a service I'm paying for. Okay, so here we go. It says how to make the bull look like a unicorn. You got to remove a horn. You got to reposition. You got to retouch the fur. And then, add some sparkle. There we go. Okay, so those are the two basic approaches for how you can send images, is with a public URL or with a data URI. And we did get a response here from and this is a really similar response because I'm using the same model in both cases, but I do encourage you to try some of the other models here to see how different the responses are, right? So if you want to, I mean, we could try a different one here even. We just go and copy the model name. And so here I'm going to pass in this instead. Oh, what's the error here? Unknown model. Let's see. Let's see what it says for use this model. 535 vision instruct. I think I did that correctly. Oh, there we go. There we go. This is good old 535. Remember, this is the older phi. So it's not possible to make a unicorn from a bull, as they are two different species. A unicorn is a mythical creature, while a bull is a real animal. Yeah, so they thought I was like trying to actually take a real bull and turn it into a unicorn, I guess. I'm not sure. So that's the thing, like you might need a slightly different prompt or, maybe system message when you're working with different models. Okay. And that could be good. Like phi can be, I think of phi as being the more serious one. So for some use cases, that's a good feature. And also phi is one that you can fine tune more easily. So a lot of people will take the phi models and then fine tune them for their use case. All right, so we saw how to send images 2 different ways. So now we're going to look at some popular use cases. One's around accessibility and then also just around more efficient business processes. So going back to our notebook here, right? So here's an example where we're going to pass in a chart. So here's the chart. It's a pretty complex chart, right? We've got like a lot of axes going on, multiple axes here, a legend, stacked columns, right? A lot going on there. And so we can ask the question, what zone are we losing the most trees in, right? And if you look here and you try and find what zone you're losing the most trees in, well, it looks like tropical, right? Like I'll just use my finger. Tropical and boreal looks similar, but overall we see more tree loss in that dark green, right? So we're going to go ahead and ask the model to answer that question and see how well it does with that. And it says the tropical zone is where we're losing the most trees, as indicated by the dark green bars in the chart. It's significantly larger compared to the other zones. So that's correct. So it's able to do analysis of chart, which might be useful if you need to do some sort of semi-automated analysis of lots of charts and diagrams and that sort of thing. All right, here's another use case that I've heard from customers is for insurance claim processing. If you're getting lots and lots of claims, and maybe a lot of them are fraudulent where people are trying to claim something else, right? So here we have a picture of a car that's been through a lot. It got a real big ding here. And the person maybe is trying to say that the damage is due to hail, right? So we're asking LLM like, hey, look at this picture. Could this damage be due to hail? Well, probably not, because that'd be like a really big hailstone, right? So here we can see it says it appears to be extensive. So it's a more significant collision impact. Hail would be more minor. So you could actually use an LLM as a first pass over claims, especially ones if you're getting a lot of fraudulent claims. You probably want to, you want the LLM to be really sure, if you're ever going to use this in order to completely dismiss a claim. The other approach is that you put it in a bucket for people that says, okay, the LLM said this was not a good claim. Can you confirm that, right? So, we want to be careful whenever we're doing full automation of something like this, because there's a big danger of overusing machine learning in a way that harms people, right? Especially with like health insurance claims, right? We've seen that health insurance claims, like the health insurance companies are in the US are not very nice about accepting claims, right? So we do want to be really careful about, any sort of over aggressive dismissing of human claims and reports and that sort of thing. But you could use it to, semi-automate the process or identify things that are really, really clearly, fraudulent claims. This was another example from a colleague. Like if you have like a crazy dishwasher, some sort of appliance, you're trying to understand how to use it, and it just doesn't make sense. And so we just said like, okay, how do we wash the dishes quickly with this, right? And amazingly, it's actually able to answer this question here. And I guess that's because it's seen a lot of people ask about either this particular dishwasher or other ones. Now, this is one that I would only use the biggest models for, because this is also like relying on a lot of information in its weights about dishwashers, right? Which is a very, particular topic. But it's impressive to see that it actually works for that. Now, a big use case is accessibility, right? So making things better for folks who are vision impaired. So for example, we have this menu, right? And this menu is written in, crazy font. Like I can barely read this stuff here, right? All this cursive with the meal names here. So we can send this menu and say, oh, is there anything good for vegans on this menu, right? So we wanted to look for things without dairy and egg. And it said, okay, here's some options. And here's also what to check for, right? So that was a really nice way of being able to get, something to quickly go over everything and say, oh, these are the possible options for you, right? But it also says what to check and confirm, right? So this is like semi-automation, right? Like we give this to the user is like, oh, what about the bruschetta trio? Is that vegan, right? You obviously want to check that with the waiter. And then another really popular use for accessibility reasons, and we already see this being used in the wild a lot, is using LLMs to suggest alt text, right? If you do like, even in PowerPoint, right, is if you click on an image and it doesn't have a caption, it'll actually automatically suggest the alt text for you. And I've also seen that on social media websites like Mastodon, and I don't remember if Twitter's doing that now, right? But generally, like, so alt text is something that we put on an image tag so that someone who is vision impaired, when they're using a screen reader, can read that alt text so that they know what an image is for. And so many people forget to write alt text, which makes for a worse experience if you're vision impaired. So we're trying to make it, make it easier for people to write alt text. So you can come up with a first suggestion using an LLM to get people started, right? So here I pass it an architecture diagram and ask it to make alt text for that. And it does a pretty good job here. And so we could give that as a suggestion, and then the user could modify it or not. All right. And then finally, what about tables? Can it understand tables? Tables are kind of hard, right? So we've got these columns. They're written in fancy font that looks like maybe papyrus here. So we got the column names written in fancy font. We've got kind of some sections here, right? So if we pass it this table and say, what's the cheapest plant? It says the cheapest plant is thin grass, priced at $0.58. And if we look back at this, we can see thin grass, $0.58. And that is, in fact, the cheapest plant. So yes, it can actually look at the entire table here. So this gives you an idea for the range of things that you could use these vision models for. It's pretty impressive what they can do. So now let's talk about how we would send in documents that aren't actually images, right? Because these models can only handle JPEG, PNG, and static GIF files. But you might have some other sorts of documents that aren't technically images, but are very visual, right? So maybe a PDF or a PowerPoint. Those are the two big ones, actually, right? So there's two approaches to using those with vision models. One approach is if you can identify find the images in that document and then crop those out and save that as an image. Now, the hard thing is to identify the image part of the document. I've done that using document intelligence. They have this figure extraction technology that'll identify the bounding box, right? So I get the bounding box and then I cut that out using Python, using the pillow package. And then I can just save that part as an image. Because that's nice, because that's the only part I actually want to send to the vision model. The rest I can send as text, just as normal text. So that's one approach. I don't have a simplified example of that code, but I do have a non-simple version of the code if any of you need that later. The other approach that we'll see is that you take the whole document and you convert it to an image. So for either of these approaches, you can use Python libraries, you can use hosted Azure services, you can use hosted services on other clouds. But those are the two general approaches that I have used in order to send documents as images. So we'll walk through an example of converting PDFs to images, right? So we take the PDF, we can send it to PyMu PDF, which is a Python package that is free. It'll work locally, and then use Pillow in order to turn that into an image. So we can open up the notebook for that. So that's in chat PDF images.ipynb. All right. So I've already got this open here. Let me run this. So what I do here is that I open up the PDF, and this PDF looks like that. Let me actually open the PDF so I can show you what it looks like. Where's my Finder? Oh, here we go. Okay. So this is what it looks like. It looks like that table, except it's a much longer. So it's just a lot of tables across a bunch of pages, right? So I open that up, and I use PyMu PDF to open it because it's a package that understands PDFs. And then, let's see, I didn't have to do that twice. All right, so then I load each of the pages, and for each page, I get the pixels from the page, and then I take those pixels and turn them into a PNG. And in this case, I actually saved the PNG locally for convenience, but you could also just directly have the PNG in memory and just use the data that's in memory here. All right, and then we've got our familiar function for converting an image to base64. And so then what we're going to do is send all of those pages. So we're going to send multiple images to the LLM. So we can send multiple bits of text, multiple images. We can send all of that to the LLM. So we're going to open every single one of those pages. You can see there's 14 pages, and send those to LLM. And in this case, I'm asking what plants are listed on these pages. Oh, I need to run this cell at the top to connect. Okay, so that's using my Azure OpenAI because I'm in my local editor now. And I'm using my Azure OpenAI because I am sending 14 images here, so I want it to be a little speedier. I see a question, is this safe for health-related documents? That's a good question because I know that I've seen that Azure AI Vision, the embedding model, specifically has a note that it shouldn't be used for trying to find that note. It's in it's like documentation. I think it's in this one. There was definitely a note somewhere where it said you shouldn't use it for medical stuff. I can't see that note now. When we here. Yeah, I don't see that note now, but I remember reading for the embedding model that it didn't recommend using it for medical stuff. Now that's the embedding model, which we haven't talked about yet. I haven't seen the same warning about the vision multimodal models, but definitely for any sort of medical use cases, you do need to be very careful. I saw even an article that came out yesterday about high rates of hallucinations when using LLMs for medical use. So I'd recommend checking out and doing some research on what has gone wrong in that sort of things. There's also, let me see if I still have it in, there we go. Okay, so yeah, so you might also want to like look at techniques like this, right? This is just about general medical use, not about vision models. But there's definitely been a lot of research into the use of these things for the medical stuff and like what goes wrong, what are the rates of, incorrect use. So it's worth researching. Yeah, I am not a lawyer. Okay, so let's go back and see how it did. All right, so we got the results from the model, the plants listed on these pages, right? And so we can see here, we can look at this whole response and see, and then we could compare it back to the original and see like, okay, is this correct, right? Did this actually answer it correctly? Because we sent it quite a lot of data. Like I think we sent it, did we send it every single page? Yeah, we sent it every page. So it should have been sent 14 pages. And let's see if we can do a quick comparison to see how it did. All right, so we started with the annuals, then we got bulbs, then we got grasses, perennials. I feel like it missed some grasses there. There's perennials, but I don't see a lot of the grasses here, so I feel like it missed some grasses. Perennials. Then at some point we get to shrubs. I feel like it missed some perennials because this is a long list and it doesn't seem as long as this, right? Then we got shrubs. So it definitely got the order of these sections right. But it feels like it's missing a lot. Sundry. So then we see sundry. And then there's tree, and that tree was in a different thing. So it actually didn't even get the order right. So what you see, this wasn't perfect, right? I gave it a lot of stuff and I wanted it to basically read out all of the text. So I was able to do it, but I got an inaccurate response, right? So this is an example where we're like, okay, well, it kind of looks like it worked, especially if we only sent it one page. If I only sent it one page, I'm more likely to get a good response, especially when I just asked it to say like, oh, I just identified the cheapest one on the page. Like that, it was able to do quite easily, right? But asking it to read off every single bit of text and report back and do that accurately across 14 pages, it just wasn't able to do that, right? So that brings me to this topic. Can you use multimodal LLMs for OCR? So OCR stands for optical character recognition. OCR is a technology that we've had around for quite a long time. And an OCR tool is something that can look at an image like this one up here and extract the text. So basically it looks for text and says, oh, okay, that word is nutrition, that word is facts, that word is serving, right? And so it can read blurry words, it can read handwritten words, right? It can do it best to try and read all sorts of text that it's been trained on, right? So it's been trained on lots of fonts, lots of handwriting, and it tries to extract and figure out what letter is what. So some people do use multimodal LLMs for OCR, but we need to keep in mind that a multimodal LLM is a generative model, which means it can hallucinate text that isn't there. Right. I had like when I actually ran this one before, instead of the list we saw here, at the end, it just repeated the same species over and over for 100 times. Right. And that was a clear hallucination, right? It was as if this species was there 100 times. So that was definitely hallucination. We would never get that sort of thing from an OCR model. Because an OCR model isn't going to make stuff up. It's just going to either figure out what it is or it's going to get it wrong, right? So like, in this example here, like it might, see from, but think that was FRON instead of FROM, and then say, oh, it's from instead of from, right? So it can make mistakes, but those mistakes, they're going to be more predictable what kind of mistakes they'll make. Whereas with a generative model, the mistakes it makes like can be all over the board, right? It's got the ability to generate whatever it wants. So if your entire goal is OCR, then I recommend using models that are specifically for OCR. So there's open source models I can use. You can train your own, or you can use hosted models, right? So for Azure, we've actually got two different hosted OCR services. There's the Azure AI OCR and the Azure Document Intelligence OCR. So check out that documentation in order to see how they work and see the differences. That is what I generally use Azure Document Intelligence when I know that what I need is OCR. And also it should be cheaper. Like generally these models are going to be cheaper than LLMs because they are, specialized models for this, and they don't have to have quite as many, as deep of a neural network. So generally it should be cheaper to use an OCR specialized model as well. So that's always important. All right. Okay, so I did see there's interest in how to crop. Okay, so if you are, I need to like write a blog post about this. I need to write a blog post about a lot of things, but basically, if you want that cropping code, let me find it. Let me just find the pull request where I added it. I think that would be the easiest way. So I added it as part of this media description feature for the RAG repo, and it's using document intelligence with content understanding. But basically what we do is when we parse the PDF, we use the document intelligence here, but we ask it to output figures. And we're using this OCR high resolution as well. We need both those options. And so then we get out figures from it. And then what we can do is we can go through the figures and find their bounding boxes. So we have this code here to find the bounding boxes. We have a lot of crazy code here in order to turn this all back into Markdown. But basically, once we find a figure, then we need to describe that figure. So here I'm using Azure Content Understanding in order to describe the feature. You could also use a multimodal model here, right? So I have a plan of like adding another option of having a multimodal model here as well, because that's a pretty good use for a model, right? So basically we find the figure, which is like an image in the document. We crop that out according to the bounding region, right? So we get that bounding box and we use Pillow to crop it. And then we can use some sort of service to describe the image. And vision models are very good at describing images. I think that's a really, really, really good use of them. And, you know, basically the service is using one behind the scenes, right? So we could either use content understanding or we can use, we can use a multimodal call. And then we embed that in our final thing that we store in our RAG index. So that's the general idea here of how to use document intelligence to crop out those figures and get descriptions of it. Okay. Yeah, so hopefully Azure Document Intelligence will make this easier to do over time. This is a fairly new thing that they added, I think, in November, and we're all experimenting with it now. All right, cool. So now let's just talk about how we would build user-facing apps with vision models. And we can use an example app that's in the same repo that I've been using so far. We also have a demo that's already deployed of this. So let me open up that demo here, right? And we can even share that in the chat as long as you don't destroy my server. So here we go. I'm going to upload a picture, right? And here's my picture. This is a picture I took when I was on a trip in Costa Rica and we were going over a bridge and we saw a bunch of reptiles below us. So we say like, okay, what are these? Crocodiles or alligators? All right. And it says they're alligators today? No way. No, they're not. They're crocodiles. Oh my gosh. Why is it saying, we did this all yesterday and it was saying crocodiles. Let's try it again. This one is it gets really tricked up on this. All right, let's try it again. Crocodiles or alligators? These appear to be crocodiles. So as you can see, LLMs are not very predictable. And I wonder actually what my temperature is for this. Let's check the temperature that we're using here, right? Okay, so we can look at the code for this, right? So this is our backend. Okay, so I'm defaulting to the 0.5 temperature. That's actually fairly high, right? So it might be better if I reduce this down, depending on the use case for this app. But 0.5 is a fairly high temperature. I would probably go for like 0.3, maybe 0.2. And that should increase accuracy. I think it's just not able to look at the snouts that well, but these are definitely crocodile snouts. So here we go. That's, one thing we could ask it. Yeah, we can just send it any image and then ask for it to read it. Okay, here's like a poster I made for a conference. Like, what's summarize? A lot of people use LLMs for summarizing research, right? Summarize the research poster in 3 sentences. Okay, so I just sent it this entire poster, and now we get a nice summarization of it. And this looks pretty good. All right, so this is a user-facing app where the user can upload images and use them with the model. So how do we build an app like this, right, that has this sort of flow, right? So the user puts in their text, they put in their image, we send it to the back end and get a response from the LLM and send that back to the user to show up in the front end. So how it works in this one is the front end is simple HTML with JavaScript. It's actually just a single page. And what we do is we actually encode the image as base64 in the front end. We just go ahead and do it in the front end and send both that base64 and the user question to the back end. The back end is written in Python using the Quart framework, which is the asynchronous version of Flask. So it gets sent to that back end to this route here. That route calls the model, and the model streams back the response so that we can see the response come in 1 token at a time. So in the front end, this is the JavaScript equivalent of that base64 code we saw from before, right? So when the user uploads a file to the form, we can then read in that file and turn it into a data URI. And that way we can actually just send that data URI to the backend just in post in our request. Let me actually go and open the network panel so you can see what it looks like. Let's do some other thing here. Oh, do I have? What is this? Okay. All right, so let's see what the network request here. What you can see is I send along. So here you can actually see the data URI that I'm sending over the wire. I'm just sending it as part of the JSON. So it's, this whole long data URI here. I also send along the file name. And then I send the whole conversation so that the LLM can see the whole conversation. All right, and here we get a nice response about what this beautiful Octocat is wearing. Okay, so then the next step, so that's the front end. So the front end sends it to the back end. And then in the back end, we can retrieve that file from that JSON body and retrieve all the messages. And we make sure that we turn that file into the right form using this multi-part content that has both the text and the image URL, and send it to the LLM. So this code basically looks like the kind of code we had in the notebooks. It's just that it's getting it from the post JSON instead of from our script. All right, so that is one way you can handle image upload from users. There are other ways as well that are a bit more complicated, but might be better for efficiency reasons, right? So you could send a post request from the front end using multi-part form data, and that way it would take up slightly less space because base64 encodings can take up more space than using this multi-part form data. So there is an example here that does that. If you want to check out that code, it is more complicated because especially if you can potentially have multiple images in it, but it's definitely a very valid way of handling it. You could also have the images uploaded in a separate step. I think ChatGPT does this sometimes, where you upload the image and it stores it in some file storage, and then you just remember that file identifier and then use that file identifier. You do have to make sure from a security perspective that one user wouldn't be able to access another user's files, right? But this would be a good approach if somebody was constantly asking questions about the same image, right? You might want to just have that image be, persistently cached for that whole conversation. You could also just cache it for a conversation and then, kick it out of the cache after a day. All right, so now let's look at multimodal embedding models. And so for this, we have another repository, the vector embedding demos. This is the same repository that we used for the embeddings talk earlier last week. So you may already have this repo checked out. So you can create a code space from this one as well. I've got it open locally. So what we're going to do is use Azure AI Vision, which has a multimodal embedding API, meaning that you can send it text or you can send it images and you can get back embeddings in the same embedding space. And this embeddings API is based off the Florence model from Microsoft Research, which is a very powerful vision model. So they've used it to build multiple vision-related APIs. So in this case, we're going to use it to generate embeddings, right? So we can take this, this photo here, and then call the vectorized image API and get back this embedding here. Or we can send in text and then call vectorized text and get back this embedding here. And both these embeddings have 1024 dimensions. So they have 1024 numbers, 1024 numbers, floating point numbers, and they're both in the same embedding space. So these two can be compared to each other. And in this case, if we compared these two using cosine similarity, we would expect to see a very high similarity, right? Because this description is very similar to this image, right? So that's the point, is that we can make embeddings of both image and text in the same embedding space so that those vectors can be compared with each other. So here's some code for how you can call that API from Python. You have to first create the Azure AI Vision service. There's no free version of it, so you have to create that service, and then you can call it and pass in your text or pass in your image. So then once we do that, then we can do a vector search using that, right? So that means we can take in an image and then say, hey, find me similar images, right? So if we pass in a crocodile, we should get back more crocodiles or alligators or whatever they may be. And then if we pass an alligator in search, we'll get back things that are like alligators, which can include crocodiles if that's the closest thing in our image base, right? All right, so let's actually check that out in the notebook. Let me go to the vector embedding demos here. Okay. All right, so I'm in the multimodal vectors notebook in the vector embeddings repo. So here I've got images and words already encoded in the same space. And the images are it's just a bunch of, I collected driftwood back when I lived in the woods and decided to turn them into things like incense holders and necklaces and whatnot. So it's a bunch of images of my weird driftwood shell creations. And then the words are just a bunch of common English words. So I've got those both embedded with the AI Vision embedding models already. And then here I've got the code to calculate similarity, right? So we've got cosine similarity. And so we can use that in order to figure out the most similar results to a particular target vector. So let's first try searching by image, right? Doing similarity by image, right? So let's say I have this image here, inhale, exhale. So it's a wood burning that says inhale, exhale. And then I ask, okay, what are the most similar ones? Now here you can see the file names, but it doesn't care about the file names. This is only based off the actual embedding. So, you might just think oh, I was able to tell because the file names are similar, but it is not looking at file names at all. I'm just showing them for convenience so you can see the file names, but it is only looking at the vector embedding of this image. So if we look at these images here, we can see that the most similar is one that says breathe. So that's really similar. It's the same thing as inhaling and exhaling. We also got an incense stick, which you might be using when you're doing breathing practices, or you might find it harder to breathe around incense. We've got a candle, another incense stick, right? So it found things that it thought were similar to breathing, meditation, that sort of thing, right? So pretty good result. The top result was definitely the best for that one. So that's just an example of okay, for an image, let's find the most similar. Now we can do the same thing with text, right? So let's say we've got this word light and we already have the embedding for that word. So we say, all right, for that word, what's most similar image, what we find is this candle that's lit up at night. And then we get a bunch of candles, right? So those are all related to light. And now finally, let's search with new arbitrary vectors, right? So for completely new phrases, right? This is the kind of thing we'd want for a product search site, right? Like if you ever been on Etsy and you're ever searching for stuff on Etsy, right? This is the kind of thing they'd want, right? So here I could say, okay, find me a mushroom shaped necklace, right? So it's going to turn this new string into a vector embedding and then use that to find the most similar images that are in here. So what we find is a necklace that is shaped like a mushroom. The rest of them aren't really as mushroom shaped, but this is perfect, right? That definitely looks like a mushroom to me. All right, we could also pass in, like, let's say we're looking for like Lion King stuff, right? Our kid loves Lion King. I love Lion King. We're looking for Lion King stuff. And boom, we get Hakuna Matata, right? So in its vector embedding space, it knows that my wood burning of Hakuna Matata is actually very similar to Lion King. Now, it's also multilingual, so we can try doing El Rey de León, which would be the Spanish translation of Lion King. Okay, that time it didn't work. What if I do, I think, I'm trying to remember what the right, where does the accent go for, I thought it was there. Okay, so today, let's try, maybe it's Rey de León. Let's try this. Okay, it's getting Hakuna Matata number 2. It depends on like exactly what you type there, whether you use accents or not. Like sometimes you get different responses, but it did find Hakuna Matata as the second one. So that's pretty good. So in theory, it is a multilingual embedding space. You want to check to see how well it's working in practice for the kind of queries you're expecting in your language. Oh, I see. El Rey León. Okay. All right. Let me try the proper way. El Rey León. El Rey León. Okay, gracias. Okay, El Rey León. And did worse that time because we did the accent. Let's go ahead and try it without the accent. Gwen and I have been experimenting with accents. There we go. Okay, so this is what's fascinating. The best result is El Rey León without an accent. That may be because during the training, it might have normalized the accent. So maybe it has a better association of El Rey León without the accent with Hakuna Matata than with the accent. So really interesting. Sometimes accents make things better. Sometimes they make stuff worse. If I was developing in Spanish, I feel like what I would do is maybe send both the accented version and the non-accent version and then like try to decide which of the results were better, or maybe combine the results. Because we'll definitely keep seeing differences whether we use an accents or not. And sometimes they're better, sometimes they're worse. In this case, it's better to not use the accents. So really, really fascinating there. All right. Sweet. Thank you. All right. Okay, here you go. Okay, so that was multimodal embedding models. So those are super interesting and really can be useful. You can use them, for like product search websites, any sort of image search. Here we've got a demo that's running to do image search. So here I can put in tree and get back a bunch of trees. I can say like birds in love and get back 2 birdies on a thing. Also some butterflies in love here, right? Some giraffes in love. Look at all these things in love here. So cute. We could also try this in Spanish. Oh, let's try El Rey León again in here. Rey León is getting back all these Africa scenes, right? What if we do this with an accent? It takes me a while to make that accent, but there's similar results, right? So we can share this. We can share this in the chat as well. It's been shared. So if you do want to try it out, you can try it out. It's just using Azure AI Search to store a bunch of images where they're embedding, so you can try out and see what it's like. All right. Okay. 5 minutes left. So we're going to talk about RAG with vision models. So we talked about RAG earlier this week. Yeah, we talked about RAG earlier this week. So hopefully you came to that RAG session, or you've come to one of my many other talks about RAG. I'm always talking about RAG, if you know me. So we do have actually multiple ways of using vision models, multimodal models with our RAG repo. So this main repo is aka.ms/ragchat. There's a setup guide for the vision feature I'm going to show today. And there's also a demo where you can try it out. So I'm going to go ahead and open that demo. Now, when I open it, Oh, sorry, mine's in Spanish. I'll change it to English for today's session. Yeah, we do have internationalization. And what I'm going to do is go to developer settings and click use GPT vision model. Okay. And that has some suggested questions here. So I can click on one of these questions here and say, oh, can you identify correlation between oil prices and stock market trends? So it's going to go off and try to answer this question based off of both text and images. And you can see it actually cited an image in its response, right? And if we look at the supporting content, we see text. Some of that text has tables, and we see images. So this is our RAG with vision approach here. And that's what I'll talk about briefly, how we did this. So this is the general flow that just happened, right? So I asked this question, and we take the question, we turn it into a text embedding, and we turn it into a vision embedding, right? So that's two different embedding models. So we can't compare the two to each other, but we can compare them against the existing embeddings in our index that match them. So in our index, we have text embeddings with OpenAI, and we have vision embeddings with AI Vision. So we do both those embeddings. So we send the text and both the embeddings to AI search, and it will do 2 vector searches and a text search, and it will combine all those results using the reciprocal rank fusion algorithm and then using semantic ranking. We talked about both of these earlier this week. So then we get back the best results across all of those. And then for those results, we take those results, both the text and the images for those results that we've stored in blob storage. We take the text, we take the images, we send the text, the user's question, and those sources to the LLM, and we get back a response. So when we're using this RAG with vision flow, we have to do more steps in our data ingestion, right? So in addition to our usual textual ingestion steps, we also do this additional data ingestion where when we have like a PDF, we split that PDF into pages, we generate an image of each page using, code similar to that notebook we saw earlier. We upload the images of each page to blob storage. We vectorize those images using Azure AI Vision. And then we store the embeddings in the image embedding field, and we store the file name of the blob storage image in another field. Now, the interesting thing is when we're generating these images, we don't simply take the PDF page and turn it into an image. We actually bake the file name and page number into the image because we want the LLM to be able to cite its sources. That's really important to us. So if we send it a bunch of images, we want to know, hey, which image did you get that response from? So that then we can show people like, oh, okay, here's the image I got that response from. So we actually use Pillow in order to make it into an image, and then we open that image, we add a little rectangle on top, and we write the file name into that image so that the model can actually read that when it's looking and making its answer. Because remember, the model only sees the image data. It doesn't see file names. It only sees image data. So we have to provide this file name in the image data itself. And then we take those images that have the file names, we store those in blob storage and get back a blob URL. And then we can vectorize those blobs within that embedding model, and we get back our embeddings. And then finally store them in AI search. So we'll store the chunk, the relevant chunk, we'll store the embedding for that chunk, we'll store the image embedding of the page it was on, and then we'll store both a link to the PNG and the PDF. So putting that all in the index. And then we're able to use this flow that we saw earlier. When we do this flow, we do have to change the system message because we have to tell it how to reason over the images. So we can say, oh, okay, make sure that you look at the file name in the top left corner. It's in this format. And when you cite your sources, make sure you cite your image source. And then when we send everything to the LLM, we send that system message, and then we also send the user's question and all of the relevant images and text sources. We send them all to the LLM. Now, there's some benefits, like there's some good things about this approach is that we're like, we're doing a really comprehensive search. We're also giving it the whole image so they can like look at anything that's in that image, but it definitely increases latency and cost. And, that's a big deal. And so we have another new approach now that you could also possibly use. I can't go, like, we don't have much time today, so I can't really go into anything more, but I've got a video that I did from our earlier RAG series where I dived into both approaches and then talked about what I think is the best approach that combines both those. So this is just kind of a preview, like a teaser, something to think about, but it's not necessarily the best approach. So I encourage you to watch that talk if you really want to dive into doing RAG with visual documents. Okay. All right. So that is everything we had to share today. I am now at 10:30. I know that I didn't get to answer all the questions. Let me see if I can quickly answer a few of them, right? So is there a way to search for personalized facial images, like photos of my son Mark on a tree? That's a great question. I would go ahead and make sure you check out all of Azure AI Vision's services. No, I don't want the embedding model this time, but I can probably find it from here. Azure AI Vision has just a ton of different options. So there's this face one. Now this one, I do think they've limited this can be particularly dangerous to give people access to good facial recognition. Like you can imagine lots of ways this has been used badly. So you do have to fill out there's like a form for it and everything. Lots of cautions here. So, check that out. You might also go on Hugging Face and find some, models for that. But you might also be able to train it, right? Like, so maybe you can't use a face service, but with the image analysis, you can do training on it. Let me see. SDK. I know there's ones where you can actually train it, like for classification, right? So let me try and find that one where you can train it. That might be something to keep in mind is whether you just want to train your own classification. There we go. Image categorization. All right. And I believe we can do, where's the custom one here? Okay, I'm not finding it here, but we want to do like custom image with custom vision SDK. Maybe this is it. Create an image classification project. All right, let's try this one. Okay, so definitely check that out. Like I haven't even explored all the things we have. So I would check out all the options with Azure AI Vision, and you may not be able to use the face service, but you may be able to do your own classification project if you already are able to say, hey, this is Mark, this is my kid, blah, 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 right? Maybe you can learn. And then you also asked what's the best way to parse out images in PDFs. So that was a code I was showing earlier. This one, we shared it earlier where I was using document intelligence with the figure extraction. So that's what I would recommend. And then passing it either to Azure Content Understanding or to a multimodal model. I'll try to write a blog post in a simpler notebook version of this at some point. And then Paulo asks, is there a repo about using vision models with prompt flow and how to deploy as an inference endpoint with multimodal capabilities? That's a good question. I haven't seen that model. I'll just take a screenshot and follow up with our team, and then I can tell you in office hours or over LinkedIn. Okay. All right. So that's a couple questions there. I see a question. Oh, on video vision models. I haven't worked with video vision models yet. There's so many things to work with that there's just only so many things I can try. So I haven't had an excuse to use with video vision models. I do know Azure Content Understanding, that might be something to check out because they do have special support for video, right? So they can do some extraction here. Oh, they've got like face grouping. Okay, so I would definitely check this out. I haven't played with it yet. But they're doing some sort of video processing. I've seen some other ones too. What was it? AI in a box. Microsoft. No, I'm looking for the GitHub one. Okay, and box, this one I think had videos. Video. Yeah, image and video analysis. Okay. Yeah, check out the examples here too. Some colleagues made these examples. And I remember them showing the video analysis one. So might be interesting to see the approach there. But also these things are changing all the time. So the way to process videos might, there might be a new best practice for it too. Okay. All right. So let's talk about next steps. Do come to the upcoming streams. If you haven't registered yet, go ahead and register so you get notified of them. We'll have ones about structured outputs and function calling, and also AI quality, safety, and evaluation next week. So those should be really interesting. If there's additional questions that I didn't get to, or if you have questions about anything related to Python and AI, come to my office hours today in 2 hours, actually. So that's on the Discord, and we'll put the link to the Discord in the chat. Sign up for our AI Agents Hackathon if you want to learn about agents. We're going to have 30 streams. It's going to be crazy, and it's across like a bunch of languages too, both programming languages and spoken languages, right? So we'll have a bunch of Spanish and Portuguese as well. So we have a bunch of streams, and we'll have prizes. It's like 50,000 worth of prizes here. So you could do best agent in Python. You can do best Azure AI agent service usage. So definitely sign up for that hackathon if you are at all interested in agents. And if you're here today, you're probably interested in agents because LLMs, agents, kind of the same thing. An agent is just, a good use of an LLM to do something useful, usually using tools. You can get more Python AI resources from this link here. And we'll put this in the chat, and that'll also sign you up for a newsletter so you can find out when new things are happening. And if you missed any of the recordings, you can always catch up with the YouTube recordings and the slides. All right, that is what I have for you today. I'll say goodbye now, and I'll see you at office hours or next week. Bye.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.